What's up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and I'm back in Mexico, so I'm super happy about that. If you're new to the channel, then you don't know, I love coming to Mexico and working remotely from here. It's one of the perks of being a software engineer and getting to do this job from anywhere. So if you need some inspiration for why you're on this coding journey to learn how to interview better for software engineering positions, use this as inspiration. It's the best life ever. Today we're going to do our last merge intervals problem. This is going to be a harder problem, something that takes into account all the things we've learned in this mini series so far and kind of raises the stakes a little bit and asks kind of a slightly tougher iteration of this sort of problem. So without any more delay, let's get into this week's problem. So let's recap what merge intervals are and what this pattern is all about. So this pattern is all about efficient techniques to deal with overlapping intervals. Often in these sorts of problems, we're asked to find overlapping intervals or merge intervals if they overlap. Little hint, in this problem, we're going to be looking at the space between merged intervals. So here's an example. Here's an array of arrays. Each one of these little subarrays represents an interval. So this one starts at 1, ends at 4, starts at 2, ends at 5, etc. So if we were to go ahead and merge these intervals, merge all the overlapping intervals, we would get something that looks like this, which is 1, 5, and 7, 9. So let's look at what that might look like on a number line, which is really helpful for this sort of problem. And I highly recommend if you're ever struggling to kind of draw it out and then reason about it after you draw it out, because sometimes that can help. So here we have our first interval, 1, 4, second interval, 2, 5, and our third interval, 7, 9. And when we merge these intervals, we get a new interval, 1, 5, because that's the combination of these two intervals. And then we get 7 and 9, which it never overlapped. So we just take 7 and 9. So this is the same as all of the other videos in this little mini series. And I just want to reiterate how important the bones are for these problems so that you can then determine, what do I have to do after I've applied the pattern to actually solve a specific problem. Okay, so speaking of the problem, what is this week's problem? Given a list of intervals representing the working hours of each employee, find a free interval common to all employees. So we're going to get a list of intervals here. So let's say this first line is going to be employee number 1, and these are the times that he's busy or she's busy. And then the second line will be employee number 2, and those are the times that that employee is busy. And our goal is to find the times where neither of them are busy, aka they both have some free time, maybe to play some games. I don't know about you guys, but my software engineering teams, when no one has meetings, we're playing games. So this is similar to a problem I've actually already done on this channel, but it's slightly different, and I want to kind of just do it again to show that this absolutely fits into this sub-pattern of merge intervals and how we could go about solving that using the scaffolding, our toolkit that we've already learned in our last couple videos, and just kind of modifying a little bit to figure out this particular problem. So if we get this, our output is going to be 3, 5. Because that is the times that both employees are not working. So again, let's look at this on a number line because it really can help. Here's our number line. Here's employee number 1's intervals. Here's employee number 2's intervals. And as you can see, it's immediately obvious once you draw it on a number line that, of course, between 3 and 5, they're both free, right? So there's that interval representing that free time that we're looking for here. Okay, so what's our approach in solving this problem? So again, this is going to be similar to all the other problems. The first thing we're going to do is we're actually going to flatten that list of employee hours to just one list of intervals. Because if you can imagine, rather than looking at the two lists of intervals separately, we are actually looking for what time do neither of them have any meetings or busy time or whatever. So if we merge those or flatten those two lists into just one list of, general intervals where people are busy and then merge them, we can determine what's the free time for every single employee. Because if one employee isn't free, it doesn't matter that other employees might be free. We're looking for times where all of the employees are free. And so if we flatten these intervals and look at it as one list instead of a list of lists, and we merge those intervals, then we can kind of find the times between all of those merged intervals. That's when all of the employees are free. So the first thing we do is we flatten that list of employee hours. The second thing we do is we sort, because once we flatten it, it's not going to necessarily be sorted, even if each individual employee's list of busy hours was already sorted. So here we have our input again, same input as before. And the first thing we do is flatten it. So that's a pretty simple operation. I think we all know what that means. Flatten and sorted. The third thing we're going to do is we're going to actually merge those intervals. And again, this is going to be similar to every other problem we've done that has been in this sub-pattern of merge intervals. And finally, we're going to find the empty space between the merged intervals. And of course, in code, I'll show you how to do that. But essentially, once we merge those intervals, which we can look at here, right? So here we have those two different employees. The first employee is in this turquoise color, and the second employee is in this green color. And we merge them into just the one merged intervals. So that means that from 1 to 3, they're both busy. And from 5 to 8, they're both busy at some point. Then we can see very obviously that the free time lies between 3 and 5 for both of those employees. So that's the approach. I love these problems because they really do follow the pattern very closely, except for that little, figure out the free time piece of it. But let's jump into coding this out, and hopefully it'll all become even clearer. Okay, so I am in Visual Studio Code. I have a totally blank file. So let's get started here. I think first let's define our function. So let's say find free time. And this is going to take a list of employee hours, right? And let's define some test cases down here. So let's say find free time. And I am just going to copy and paste from the slides our examples. So this is the same exact example from the slides. We're expecting to get, we are expecting to get the interval, the free time interval of 3, 5. And then I have a couple other test cases prepared. So let's say find free time. And in this case, our free time is supposed to be, let's see, it is supposed to be 4 and 6, and between 8 and 9. And then finally, let's get one more. And here we expect the interval 5, 7. I'm just going to put this in an extra, because theoretically we're turning a list of lists because each interval is a list, and we might have multiple intervals of free time here. So that's why I just changed that. Okay, so we're all set with our test cases. Let's get into coding. So what is our first step? The first step we want to do is flatten the employee hours, right? We want it to be just one. We just want it to be a one layer, one level of arrays in one array. So just a regular list of intervals, right? So I think I'm going to use Lodash for this because Lodash has a very clutch flatten method. And in case you don't know how to use a library in just a script that you're writing, you can either two things. You can just install it globally, which I already have on my system. So that would just be like npm install -g, which is that global flag, Lodash, and then you kind of have it in your whole file tree to use. Or you can create kind of a project for this script, make a package JSON, and install it just locally in your directory that you create, which is, will hold your package JSON and your code file. So I've already done that, but go ahead and install Lodash if you haven't. And let's say const underscore equals require Lodash. So there's our Lodash. And the first thing we're going to do is say const flattened. And let's say we're going to underscore dot flatten, and we're just going to pass in those employee hours. And let's just make sure we get what we expect. Let's see, so node code. And here we get our, we've made it from a list of lists of lists to just a list of lists. So that's good. That's exactly what we want. But as we can see, they're not sorted because we just flattened them. And they might have been sorted per employee before, but now we have to sort them as we've done for all of our other merge interval problems. We have to make sure all the intervals are sorted before we go into actually merging them. So while we have Lodash, we can use Lodash to sort as well. So we can say const sorted equals underscore dot sort by, and sort by takes the collection, so that will be flattened, and then it takes this iterate, and the iterate is going to be just a function that goes through and does what it's supposed to do for each element in this list to sort it. So I believe for sort by in Lodash, this just gets like a 1, right? So this is just going to be like interval, right? And then we just want to sort it by the start time, which is the at the 0th index of each of these subarrays. So let's say we just want to return the interval at 0. And I think that should sort the whole thing. So let's say console.log sorted. And now, as you can see, we have those same flattened arrays, but they're sorted. Perfect. Okay. Get rid of you. Get rid of you. Okay, so the next piece is going to be, again, exactly the same as all of the other problems we've done with merge intervals. Very, very, very straightforward, in my opinion. Once you know this, you're almost golden for the whole problem. You're so close with these, especially. So let's say we want to have our stack, which we're going to use to represent our merged intervals. So let's say const merged intervals, and this is just going to be an array. And the first thing in the array is going to be the first thing in that sorted array that we've created. So let's say sorted.shift. And now we have essentially taken that first thing from the sorted array and we've initialized it as our first merged interval. And now we're going to continue to kind of slurp the rest of those values into the merged interval that we just initialized with. And we're just going to keep adding and modifying that merged intervals array until we've exhausted that sorted array. So handy dandy while loop. So while the sorted intervals, sorted, I called it, while it has length, we basically want to continue to go through the sorted and compare it with the merged. So let's say our const A is going to be merged intervals dot pop because we want the last thing off the stack. Remember, everything with a stack is first in, last out. So that means the last thing in will be the last thing out. So that's where we're using pop here. And then our B is going to be the first thing, the next thing off of that sorted array. And we do want the first thing off of the sorted array because that's the next earliest interval. So let's say sorted dot shift. So that's going to get the next one. And then we're just going to do the same comparisons that we've been doing all along. So I think first let's pull out all of those values from these intervals. So let's say our const A start and B, A end is going to be from A, and then const B start and B end is going to be from B. And now we have our values that we can compare to each other. So what are our two cases here? Our two cases are either they overlap or they don't. So let's cover if they don't first. So if they don't overlap, that means that if B start is greater than A end, so they don't overlap at all, right? That means we need both of them. There's no overlap. So let's say that we want our merged intervals dot push, and we want to push A, and then our merged intervals push B. So we've taken both of them, and now B will be our next interval that we look at here, right? In our next iteration of our while loop. The B that we just pushed will be the last thing in our merge intervals array. Hopefully that makes sense. Okay, what do we do if they do overlap? So this is, again, very straightforward, exactly the same that we've done for all the other problems. We make a new interval, which is going to be an array, And the start time, which is just the thing at the 0th index, is going to be A start, because we know that either A is earlier than B because it was sorted, or they're the same, so it doesn't matter. So we can just take A start. And then we just take the maximum end. So between A end and B end, we take the maximum of that, and that will be the end of this interval. And that's it. Then we just push merged intervals. We push that C onto that. And then this becomes our next interval that we compare. So this will be our next A, right? I think before I might have said our next B, but it's our next A. And that's the whole thing for our merged intervals. So let's just console log what merged intervals looks like. I'm going to clear this out. Okay, so B start is not defined. Okay. All right, so we have our merged intervals, and this is exactly the same as always. Let's look at our test cases. So we have 1, 3, and 5 and 8, because 1 and 3 and 2 and 3 overlap, and then 5 and 6 and 6 and 8 becomes 5 and 8, etc. We do that for each of the test cases. Okay, so what now? Now we have these lists of intervals, and essentially what we're looking for is the time between them, right? The time between each interval is when both employees are free. So how do we do that? So I think I don't know if this is the most elegant way to do it, but it's certainly an easy way to do it, and I think it's easy to understand. I think I'm just going to loop through those merge intervals, look at the end of one and the beginning of another, and make a new array and just say, take the end of one, the end of the first one, the beginning of the second one. That's our free time interval, right? So let's say const free time is now going to be an array we're going to push to, right? And then we're just going to return that free time at the end. And for here, we have Lodash. Why not use it? I'm just going to do a for each loop. And we're going to loop over those merged intervals. And then for each of the intervals, right? So that's going to be the interval. And I think, And I think for this function, the second argument that's, gets passed to this iterate is the index. And I'll show you in a second why I need that index. But basically, we're going to be comparing this interval to the next interval in the array, which will be whatever is at the index we're at plus 1. That's why I'm using the index. And we're going to take the end of the first, the beginning of the second, call it a day. So the first thing we want to do is make sure we're not at the end of our array. We're not at this last one, because obviously there will be no next interval. There's no more free time that's possible. So let's just say right here that we're only going to do anything if merged intervals at the index plus 1 is a thing, right? If that's not undefined. We're only doing stuff if there is a next one. So let's say the end of the first block, so let's say, right? I'm just going to write that down just so we know. If we haven't reached the end of our intervals. Okay, so let's say our end of the first interval is going to be, I don't know what's going on here. Okay, the end of the first interval is going to be that interval, right? And it's going to be whatever's at the first index, right? So because every interval has a 0 and a 1 index, and the 0th represents the start time, and the first represents that the end time. So this is going to be the const end of interval 1, right? And then the next thing we kind of need is the start of the next interval, right? So this is going to be the start of interval 2. And that is just going to be not the interval, but it's going to be merged intervals at the index plus 1. So that's the next interval that would be in the iteration. And then we're going to take the 0th index of that, which is the start time. And that's like the whole thing. We're just going to now put this in its own thing, right? So now we're going to say free time dot push, and we're going to add that end of interval 1 and the start of interval 2. And I think that should do it. So let's see what we get when we run this. And let's see. So we get 3 and 5, 4, 6, 8, 9, and 5 and 7. So we did it. That's the whole thing. So again, this is kind of categorized as a hard problem, and it's not that hard once once you have the merge intervals toolkit all ready to go. So I think the pieces that you might get like tripped up on this problem is knowing that you want to merge all of the intervals for all of the employees first. And the reason we do that is because we're looking for the time between the intervals that no one has meetings. So we actually have to take into account everyone's meetings at once. And then kind of knowing how to use that array to determine those free spaces between them. So I think those are the two kind of gotchas in this algorithm. But otherwise, I would say it's not that hard once you know how to do it. So I hope this is kind of gives you some hope in terms of these problems and really mastering them. And yeah, that's it for this week's problem. That's a wrap, people. That's it for merge intervals. Join us next time. We'll be exploring a new interview pattern. And yeah, everybody stay eager. You got this. See you next time. Bye, everybody.